Alrighty, moving into part 2 of section 4.3. I want you to see something on the next page real quick. Alright, so a couple relationships we should start recognizing as we're seeing these guys. So as far as these trig functions go, keep in mind that as I look at any point on this graph, here's what we kind of finished with in the last video. But however far you are traveling left and right is our x-coordinate, your up and down is your y-coordinate, and that always produces this radius that we see right here. So remember that in order to get the radius, we've been using Pythagorean theorem, so it looks like this. So I see the sine of an angle. So remember, however far I traveled left was my x, however far I traveled up was my y. So if I wanted to do the sine value, here's my reference angle, right? So my sine does opposite over hypotenuse. Well, the opposite was how far I traveled up. That was my y-coordinate, right? My hypotenuse is my radius of the circle. So if I did opposite over hypotenuse, that's like doing y over r. So we always want to see the sine of our reference angle as y over r. Our cosine was adjacent over hypotenuse, and the adjacent side is how far I traveled left or right. So that's going to be the x over the r. And as far as getting the tangent, right, we know tangent is opposite over adjacent, so y over x, as we want to see it that way. So we're going to be able to start taking some shortcuts here as we start seeing this relationship always play out. And of course, these guys are just the inverses of those. So cosecant is going to be the radius over the y-coordinate. We have our radius over the x-coordinate, and then x over y for cotangent. All right, so keep those guys in mind as we take a look at this next example. So something that we did similar as we ended the last one is they gave us like an ordered pair, right? Something like this. And we were using that to find the other trig functions. So even as I look at something like this, of course, if I did a little Pythagorean theorem to find my missing value right here, I'm looking at a 3, 4, 5 right triangle. Right, and we always know that depending on where I'm at within my drawing, we know that anytime I travel left or down, I'm looking at a negative number. So I do want to associate this with a negative since I'm in quadrant 2. So ultimately, that creates a point, right, like a Cartesian point, right, like an XY point, where I went left 4 and up 3. So it produces this point, negative 4, 3. Right, as I look at this. We know that the radius or the hypotenuse was 5. So now if I wanted to start finding points on this guy, right, the things like cosine, sine, cosine, all that type of stuff, I see all the relationship of these numbers, and I can find things like, so here was our reference angle, theta, right? I can find things like sine, which is what they're asking me to do for this. They want me to find sine and tangent. So as I look at this, I know that the sine of my angle here is opposite over hypotenuse, or 3 over 5, but I can also look at it as the y-coordinate over the radius, right, and get 3 over 5 that way. I can get tangent by doing opposite over adjacent, or, remember we said on the last one, it's also the same thing as y over x. So if I just have a point, right, I can see it as the y-coordinate over the x-coordinate. One of the things I also wanted you to see on this one is how did they know where to draw this diagram? Like, how did they know it was quadrant 2? Here was the information they were given. We were told the cosine was negative, and we were told tangent was negative. Right? So they're also saying that the tangent is less than 0. So where would we find, or what quadrant would we find, a negative cosine and a negative tangent? And I talked a little bit about this at the end of the last video, but there are certain quadrants we want to make sure we're familiar with when we're looking at signs of positive and negative, and we should kind of know where to draw these things. So where would we find a negative cosine? Well, remember, cosine is we associate with the x-coordinate, and cosines go left and right. So negative cosine means I'm going left, right? That's why we get the -4 as I move to the left. But how did I know whether I should go here or here when I made the drawing? And that's why they're telling me this. Well, where would I find a negative tangent value? And so there's a few different ways we could come up with that, but I wanted to remind you of this little acronym. You probably have seen this in Algebra 2 last year, I think, but if not, let me just throw it out there again. We often use this all students take calculus acronym, or you could say all seniors take calculus, whatever, as long as you remember the order that these go in. I always said all students take calculus, but anyway, what this little acronym tells you is it tells you in which quadrants are your values positive. In which quadrants are your values positive? All are positive in quadrant 1. My signs are positive in quadrant 2. Tangent is positive in quadrant 3. Cosine is positive in quadrant 4, right? And so just knowing that little acronym, when I see something like this, when I said, how do I know if I should go into quadrant 2 or to quadrant 3? Well, if my tangent is negative, I know based on this little acronym that in quadrant 3, tangents are positive, right? So I must have been in quadrant 2 in order to create my drawing. So that's how they knew to go here instead of here, right? It's just based on the signs of this stuff. So anyway, to finish all that off, this is what told us which quadrant to draw it in. We use Pythagorean theorem to get the radius. I'm sorry, in order to get the y-coordinate of that one right there, right? And so that's how we kind of finished off all this information. Then we were able to say, okay, now I can use things like opposite over hypotenuse to get sine, or I could say y over r, the y-coordinate over the radius in order to get my sine, things like that, right? As we start making all those connections and putting all these pieces together. Let's look at this one, part B here. I think we got that one on the next page, so let me flip. So as you got to part B and they came up with those two drawings, here's where it came from. On part B, they said, sorry, here I am. They said that the secant was 5 over 3. Well, secant is just the inverse of cosine. So again, they are telling me that my cosine is positive, right? So if cosine is positive, remember cosine is your x's. X's go either left or right. If my cosine is positive, I must have gone to the right. And you'll notice that these are the two quadrants where your cosines are positive, because they're all positive in quadrant 1. Your cosines are positive in quadrant 4. So here's where we say, okay, so how do I know if I'm in quadrant 1 or 4? Well, my signs are positive. My sign is greater than 0, right? So it cannot be here, because even though my cosines are positive in quadrant 4, my signs are negative. So I must be here where they are all positive. So I knew to draw this one in quadrant 1. So we got the cosine of 5 over 3. So let me take you to their drawing. If I can get these pages unstuck. So here's where we look at their drawing, and they said, okay, they were told that the secant is 5 over 3, right? We know secant is the inverse of cosine. Cosine was adjacent over hypotenuse, right? So we have that relationship right there. Of course, they use Pythagorean theorem to get this. So the point that we are working with for this problem is the point 3, 4. So as I go on to find my other relationships like sine or tangent, remember, if it's sine, I can do things like opposite over hypotenuse, or even without the drawing, I could have looked at this and said it's my y-coordinate over the radius. Right? So I want to start making sure we're getting that connection as to the x-coordinates that we're going to be associating with cosines, the y-coordinates as we're going to be associating with the sine, right? And then the radius that we associate with the hypotenuse of that drawing, right? We want to see that constant connection it's going to help us identify all these things that we have to identify. The one other thing I wanted to mention, and we're going to do one on our own for practice here, is look at the third one. Cotangent was undefined. So where do you get an undefined tangent value? In your undefined values, that means you're not in a quadrant, you are on an axis, right? So where do we get those undefined values? So if you think of just using a radius of 1, right? As I go to the right, 1 and up 0, or if I go 0, 1, or if I went left 1, 0, or if I went 0 and down 1, right, we get these points like this, right? So as we've already talked about, I know the tangent, right? The tangent of an angle is simply the y-coordinate over the x-coordinate, right? We've talked about that already in this video. So it's y over x. Well, if you look at these points, at which ones, if I were to do the y-coordinate over the x-coordinate, would I get something that's undefined? Right? Well, if you look right here, if I did this y over this x, well, I would just get 0. But if I did this y over this x, I get something that's undefined, right? And same thing with down here, y over x. That should be. So as I see these guys, my tangents are undefined. If we were to do cotangent, that's just the reverse order. So now it would be x over y. So I would be undefined in those two places. So they want me to be looking at these 2 points because they said cotangent is undefined. I think they made an error here because they said sine is positive. As you look at these 2 points, remember the sine is your y-coordinate. And on both of these, our y-coordinate is 0. It's not positive or negative, so they either meant to put tangent here or cosine here because what they did really doesn't make sense. So let me just do this and change this to say cosine is positive. So cosine is our x's, right? Because cosines move left and right, as we've been talking about. So as I look at those 2 points, how do I know which one to refer to? Well, if my cosine is positive, here's where my cosines are positive as we move to the right. So they must be referring to this point right here. So now I could link that, though, to all my other relationships if I just look at this. So I know that my sine is my x-coordinate. Sorry, my y-coordinate. So my sine would be 0. My cosine would be 1. I know that tangent is sine over cosine. Sorry. Sine over cosine, 0 over 1, which would be 0. So I can get all those other relationships. And again, a big part of that all goes back to this, right? And so that's why we want to remember that we're going to associate the sine with our y-coordinates over the radius. Our cosine is the x-coordinate over the radius, and tangent is always sine over cosine, or y over x. Let's jump down to this one. Put some more of that together. I did mention up above, I threw this in here, that, so keep in mind if the radius is 1, which would be our unit circle, that's why they call it the unit circle, right? The radius is 1. So then when you do something like sine over cosine, or let me just show you. So then if I do something like this, right, where if my radius is 1, then simply the sine is just my y-coordinate, cosine is just my x-coordinate, this is still here. All that stuff plays out when we start doing that unit circle. All right, so as we look at this one, now just using all that information to come up with all these trig values for any angle. As we look at 225 degrees, so I already made the drawing for that. Again, drawings are super helpful for this stuff, so I always encourage you guys to use a diagram. So we traveled 225 degrees. We're going to start looking at our reference angles on this one. Remember, the reference angle is always connected to the x-axis, never the y-axis, so I know I want to draw my triangle here. So it's going to look something like this. Here's my right triangle. So what's key about this angle, though, is if we travel 225, so from here to here is 225, what is just the reference angle, right? So if I ditch the 180 degrees that was up here, so if I did my 225 minus 180, I see this as a 45 degree angle, And naturally that needs to stand out to us. We have our 45, 45 right triangle. Remember, we always knew that the legs were the same on this. So I'm going to call this 1 and this 1. And what do we know about the hypotenuse? Is we get from the leg to the hypotenuse by multiplying by the square root of 2. So it looks like this. And let's also keep the signs in mind. I know that anytime we go left or down, I should have negative values. So a couple things we can link to this. If I write that as an ordered pair, I went left 1, down 1. As we've already talked about, the x-coordinate is associated with the cosine, y-coordinate is associated with sine, and tangent we know is sine divided by cosine, which would be a positive. So if you take that back to our all students take calculus, just want to point this out. So remember the whole point of that is that told us which functions are positive in those quadrants. They are all positive in quadrant 1. Your sines are positive in quadrant 2. Only your tangents are positive in quadrant 3. And only your cosines are positive in quadrant 4. So as I look at this, I can see how that plays out. My cosine and my sine are both negative. Only my tangent would be positive in quadrant 3, as I did sine divided by cosine, or y divided by x, right? And so I can see those relationships all being connected here. So I know everything looks good. Oops. So the sine of our reference angle, we would do opposite over hypotenuse, negative 1 over rad 2. Of course, we don't leave it like that. We're going to rationalize that denominator to get negative rad 2 over 2. It does help for cosecant though, right? If we said negative 1 over rad 2, if you flip that, would just be negative rad 2. For cosine, I can now do, so cosine of our reference angle, we would do adjacent over hypotenuse, negative 1 over rad 2, which would be negative rad 2 over 2. And then all that makes sense, right? The x's and the y's were both the same on this. We can see the isosceles triangle because it's a 45, 45, 90. So that's why naturally these guys are going to be the same in a situation like that. As far as tangent goes, tangent we already looked at. I can do opposite over adjacent, or I could do sine divided by cosine, right? Well, what's anything divided by itself? Would be positive 1. Flip that upside down. Cotangent's also positive 1. So we're going to start using those things. So if we said evaluate tangent of 5 pi over 3. So on this one, again, really helps to have a drawing. Where would we find 5 pi over 3? Remember, this is pi over 2. You know, this is pi. This is 2 pi over 3. Or sorry, 3 pi over 2. You know, this is 2 pi. So in which quadrant would you find 5 pi over 3? And here we go. Okay, so keeping on here. So if we're going to convert this thing to degrees, we would see that as about 300 degrees. Well, 300 degrees. All right, let me give you that drawing. My video has been real glitchy this morning, so I completed the drawing. So we drew this one here at 300 degrees. Because this is 360, we know that left us with this reference angle of 60 degrees, right? So what we're looking at is our 30, 60, 90 triangle. We know the pattern for that, right? From the short leg is 1. The long leg is rad 3. Hypotenuse is 2. Anything that goes left or down, we want to make sure we get the negative in there. And now that we have the drawing complete, now we can do things like finding the tangent of that reference angle right there. So from here, I'm just looking at opposite over adjacent to give us the tangent of that angle. What if we can't draw the right triangle? What if we are sitting on top of an axis, and so you can't draw the right triangle because you're already on the axis? I dealt with one of those a little earlier on in the video. So if you look at something like this, so they call these quadrantal angles. So how do we evaluate when we're sitting on that value? So at 1, 0 or 0, 1, or negative 1, 0, or 0, negative 1. So remember, as we talked about these a little bit before, we can always associate the x-coordinate with our cosine, the y-coordinate with our sine, and y over x as the tangent, right? And so that's why it really helps to be familiar with those things and those connections to our main trig functions when we see those guys. So let me take you over to some of these. So I wanted to try one of these with you guys that we saw a little earlier on. We're going to throw this into the next page. We're going to discuss this guy. We'll do some final examples if you need some practice. And we'll talk a little unit circle as well. So just take a peek at this one. If we are looking to evaluate things without a calculator, so what happens if they give us some crazy huge like sine value like this, right? So one of the things that we can do is when they give you something super outside of one lap around the circle, we want to shrink this down to put it into familiar terms. So on something like this, obviously if one circle goes from 0 to 2 pi, this is way beyond one circle, right? This is many, many, many circles down the road. So we're going to basically subtract out multiples of 2 pi, right? So I could subtract out 10 pi, I could subtract out 20 pi, whatever is needed in order to get me back to a value that's between 0 and 2 pi, right? We want it within one lap around the circle, not 20-some thousand laps, right? So as I look at this, right, what they did was they said, well, let's take out a bunch of 2 pi's, right? So it's like subtracting 2 pi multiple times in order to get it down to simply pi over 2. And then we can evaluate what's the sine of pi over 2. So based on the one that we just did, remember that pi over 2 is right here. And so if we just looked at the ordered pair for that, we know that sine is our y-coordinate. So we can see it now as just a value of 1 for something like that. So if they give you something that's like way outside of the typical circle, right, we always want to be able to condense that down into familiar terms to work with it. If you look at the second one for cosine, so same kind of issue on this. We want to get this into some familiar terms for that. As you look at this one, neither one of those are values that we would be familiar with, or neither one are values that you can't combine these together, right? I can't subtract these guys when this is something completely different than this one. So what they did was, so all this is about trying to somehow get these guys connected. What they did on this was they took the 142.5. This is 8 units bigger than this, right? They have a difference of 8. So they said, what if we can rewrite this as simply 134.5 plus 8, right? So they kind of separated out the 8 in order to make this equal to this, right? So now these guys, we can see they are actually the same angle, because no matter how many laps around I take around the circle, I'm always traveling in values of 2 pi. So if I go around 8 pi times, right, that puts me right back to where I started. So 134.5 pi plus 8 pi is simply 134.5 pi, right? Because you can take out multiples of 2 pi, and it puts you right back to where you started. So now we recognize, okay, this is actually the same angle as this. So we don't know what they are, but whatever they are, they're the same. So if I'm going to subtract them, I'm going to have nothing left, right? It's going to come down to 0. One last one, we'll peek at this guy too. So the tangent of pi force minus this big gigantic angle. Tangent repeats in terms of pi, right? So your tangent values are the same every pi units. So unlike sine and cosine repeat every 2 pi. Tangents repeat every 2 pi as well, but they also repeat even smaller than that. They actually repeat every pi unit. So my tangent here, right, is the same as tangent right there, is the same as the tangent right there, and right there, So when I have a tangent of a value, it doesn't matter how many multiples of pi there are. I can take this out and be right back to where I started. So the tangent of pi over 4 minus, no matter how many multiples of pi you put here, it's the same thing. It's just the tangent of pi over 4. Right? It's going to put me right back to where I started. So as I look at the tangent of pi over 4, so tangent of pi over 4 would be right here in our first quadrant. That's simply 45 degrees. Right? So no matter how many times I do this around the circle, 11,000 times, 11,000 pi times, right, it's going to put me back to having the same value as the tangent of pi over 4. So if we took a quick look at the tangent of pi over 4, which is 45 degrees, would be our reference angle. Remember the pattern on 45 90s are 1, 1, root 2. So tangent would just be opposite over adjacent, which is 1. Right? And so again, all these are about putting them into terms that we can work with, or getting rid of what's not needed to put it back within one basic circle. So let me do these two last problems with you. One thing that I did put into the notes with this on the next page is your unit circle. So that's something you should be filling out, as we'll be using that moving forward. So that's something you could easily pull up and fill out. So let's do a couple practice problems here. So if we're going to do cosine theta equals 3 over 5. So again, remember in a basic setup here, whether you did the all students take calculus acronym or just recognize that cosines are your x's, they move to the right or to the left, right? So according to this, I'm going to the right because it's positive. So how do I know if I should draw this within quadrant 1 or within quadrant 4? Well, that's why they tell me this. They said tangents are negative, right? Well, they're all positive here. So tangents are negative here, which means I need to draw it in quadrant 4. So this is our reference angle. So cosine we know does adjacent over hypotenuse. So adjacent over hypotenuse. So we're looking at a 3, 4, 5 right triangle. Anything that goes down is negative. And so now we could evaluate any of our trig functions based on that drawing, right? So now you could do the sine, right, and just do opposite over hypotenuse, whatever. You could do all 6 functions just based on that drawing. So what about where the cosecant is 1 and the tangent is undefined? Both of these pieces of info should stand out to you as we must be on an axis, right? Because where else would I get a cosecant value of 1 or a tangent that's undefined? Either one of those things are only going to happen when you're sitting on top of an axis. So the question is, which axis? So for this one, if my cosecant is 1, remember cosecant is just the inverse of sine, just the reciprocal, right? Well, if you flip 1 over 1 upside down, what are you going to get, right? It's still 1. So if my cosecant's 1, my sine is also 1. So, and we always relate the sine values to the y coordinate. So where's my y coordinate 1? Well, up here, if I go up 1, it's 1. And that would be the only place, because if I'm down here, my sine is negative 1, right? So it must be up here on this point. So, and that would also mean my tangent is undefined. So I'm looking at the point 0, 1. You can see tangent would be undefined because remember tangent does sine over cosine or y over x, and that would put 0 on bottom, making him undefined. I know this is my cosine, right? We always associate the x with our cosine, so my cosine would be 0. So I can get all of my functions just based on this. So my tangent would be 1 over 0, so he's undefined. My cotangent would be 0 over 1, so that would just be 0. But again, I can pull all those points right off of this guy just based on that simple drawing. So that is it for this section.